Hi everyone. So today we're going to do section 3.4. 3.4 actually has two sections, so today we're going to do the first one, and then next time we see you we will do the second day. Alright, so if we remember back in 3.2 and in 3.3 we talked about exponential and logarithmic functions. Okay, they are inverses of one another and they go hand in hand. All right, if you remember the exponential functions, it has the exponent in the function, and logarithmic has what we call log in the function. All right, so when we talk about 3.4 today, we're just going to be solving some more. We solved some in our last set of notes on 3.2 and 3.3, and today we're just going to be working on more conversions and more of those properties, those four properties that we talked about last class with the product and the quotient. And then we're just working on solving for x, and we got about 7 problems to go through. All right. But before we go through all of these, I just want to touch on our graphs that we talked about for logarithmic functions. So if you remember the graph that we drew for a log function, so for example, if I said y equals log, let's write here log base b of x, okay, I know that I had the coordinate 1, 0. So I can plot that on my picture here. All right. And then when I go to draw my picture, it's going to look like this. And I want you to pay close attention to that x value on this line. Okay, log functions are never, ever going to cross the y-axis. All right, if you look closely, it's going to approach the y-axis, but it's never going to cross over. And with that being said, take a look at any of the x values here on the left. Okay, can we have negative x values with this function? No, we cannot. All right, but more importantly, it's not so much the x values that are negative. I know that my log function is never going to have negatives on the inside. So we want to keep that in mind as we talk about our notes. So if I were to make a quick note here, I would say because of the graph, log cannot be 0 or negative. Okay. And what that means is if I have some function, log, we'll say base of 2 this time, whatever is inside of these parentheses can never equal 0 or be negative. All right. If that occurs as I'm solving any of these functions that I'm about to go through, if I ever get a 0 inside any of my logs or a negative inside any of my logs, I know that it is not possible, so I may have no solution. That is a possibility, all right, because of that graph that we drew at the beginning. So our directions for questions 1 through 7 is to just simply solve. And in order to solve, I am going to be making conversions. Okay, and if you think about it, our two conversions were logs to exponents or exponential, and vice versa. I can go from exponential to log. All right. If ever I'm solving something by hand, though, I want to try to get it into exponential form first so that it can help me in the calculator and it can help me while I'm solving it by hand. All right, so when I look at question 1, I'm given logarithmic, so I want to convert it into exponential, okay? Always aim to solve it by hand first, and then when needed or when we can use the calculator to check our work. So solve by hand first, all right? We cannot use a calculator for this question because if I type this into the calculator, I would have to use the value x, but my calculator doesn't know what the value x is, so that is why I am solving for it by hand. So I'm going to convert from logarithmic to exponential. So I bring down my base of 4, keep it on the left-hand side. It started on the left-hand side. I'm going to keep it there. And then the other two terms, my x plus 3 and my 2, are going to switch sides. So my 2 now becomes the exponent on 4, and x plus 3 now gets brought down. All right. Now with my log completely gone, I'm working with an exponential function, and I can continue to solve like I normally would any algebraic equation. 4 squared gives me 16. And I'm solving for x, so I'm going to subtract 3 to both sides. So I know that at the end, x is going to equal 13. All right. Now, I technically shouldn't have boxed this in. I should actually check that 13 and make sure it works. If I took this 13 and I plugged it into those parentheses there, that would give me log base 4, 13 plus 3 equals 2. We'll do a quick math here. We're just checking to make sure that we're never going to get 0 or we're not going to get a negative. So inside those parentheses, I'm going to get a 16. That checks out. I know that I can do that. So then I can box 13 and say that's my final answer. All right, so always make sure you're taking your answer and you're checking back into your logs to make sure they work. So let's try question 2. All right, we are given 3 natural log of 2x equals 12. All right, we have this 3 out front, so we can do one of two things. I know it is considered to be a power rule, so I can take that 3 and I can put it into the exponent here. So I'll show that way first. So we now have ln of 2x cubed equals 12. All right. Well, what do we know about natural log? We know that it is really called log base e of 2x cubed equals 12. And then I can convert. E to the 12th power equals 2x cubed. Now you have this handy dandy thing on your calculator. In fact, you have an E button on your calculator. So we can type in e to the 12th. So if I go to my app here, if you go to your calculator, there is an E button and it's right above the LN button. So you'll see it there in blue. Well, we have to hit second and then LN and you'll see E. When we do that, we're going to type in E. It's going to automatically tell us that we're typing in the exponent. So I'll type in a 12. We got quite a big number there, but that is quite okay. We will copy that number. So we have 162,754. So I'm going to copy that down. 162,754. And then always include a few more decimals as well, just so we don't lose our rounding. So I'll say 0.791419. 791419. All right. That's all just for e to the 12th power. And I'm going to continue. I forgot to put parentheses around those 2x cubed. I'm sorry. All right, that cubed has to go to both the 2 and the x. So when I cube everything, that's going to be 8x cubed. And again, we're solving for x. So I'm going to keep trying to get x by itself. So I'm going to divide everything by 8. There's no negative there. All right, go back to my calculator. And since my answer was already there previously, I can go straight into dividing by 8. I get 20,344. Write that down, 20,344. Include a few decimals so we don't lose track. 0.3489. And this time it's going to be equal to x cubed. And last but not least, I can take the cube root because I want to get x by itself. So I'm going to take the cube root of both sides. And when you do that in the calculator, you are actually going to go to the math function because cubed root isn't an actual button. We only have a square root on the calculator. So we have to type it in nicely. So on the app version, go to math. You're going to go down to the number 5. And then it will allow us to type in the exact root ourselves. All right. If you're working on the older calculator, kind of like the bulkier calculator, you'll have to type in the root first before you go and select that math button and find number 5. All right. That's just the way that the calculator wants you to type it in. So make sure you're typing it in correctly. I'm going to do the third root of the number. And it's the same number that we just had recently in our calculator. So I'm going to use that previous answer by hitting second and the negative sign down below in that corner. That's going to take the answer that I previously got, and it's going to take the cube root of that. And I will have 27.299. Now this is my final answer that I'm talking about. So as a rule of thumb, when you get to your final answer, I'd recommend just round to the nearest hundredth. All right. I understand that this answer, when I round to the nearest hundredth, it's actually going to make me round my actual 10th position, but that is okay. As you do your homework and your study guide and your test, just stick to the nearest hundredth as we go through. So this would round to 27.30. 27.30. And that's going to be my x. Okay, lots of calculator work on this one. We can totally do it. All right, again, take this answer. You're going to plug it back in to that set of parentheses with your natural log, and just make sure that it's not going to be 0 and make sure that's not going to be negative. So if I plug that 27.3 in, it's going to give me a positive value still, so I know that this answer will work. Okay, now this was kind of a bit of work. So another way we could have addressed this is we could have, if I rewrite the problem, I'll just write it right here on the right here. 3 ln of 2x equals 12. I understand that this 3 is representing my power. Okay, it is one of our rules. But remember, we're just solving for x here. So I know that 3 is really being multiplied by natural log of 2x. So if I want to get rid of that 3, another way to get rid of it is to divide everything by 3. And when I do that, I would be left with a natural log of 2x equals 4. And I can continue by converting that natural log into log base e, and then getting it into exponential form, e to the 4th power equals 2x. Using my calculator, finding e to the 4th, whatever that value was, dividing by 2, and then I would have the same exact x value. So the initial problem that I did, probably the longer version. This one's probably the shorter version. It just depends on how you want to get rid of that 3 at the beginning. Either way is fine. Honestly, it's just the longer version versus the shorter version. Okay. For question 3, if we go ahead and look at question 3, right away we see that we have 2 logs. All right, well, before we do any sort of conversions from logs to exponential or exponential to logs, I can only have 1 showing. All right, so when I look here, I see that I have 2 logs, but more importantly, those 2 logs are getting added to each other. So just like our notes last class, we want to use the product rule. Because I'm adding those logs together, I want to use the product property. Okay, make sure you review those notes if you need to. What the product property tells me to do is I'm going to condense these 2 logs into 1 log, And when I get to the main terms, I'm going to multiply them together. And it's still got to equal 3. I'm only focused on that left-hand side. I combine them together. All right. Let's simplify that log really quickly. So it's still log with a base 2. And that gives me x squared minus 7x still equal to 3. Well, I don't know how to solve logs by hand, so what I'm going to do is I'm going to convert it to exponential form. Same way we know and like, all right? Bring down your base. Your base was on the left-hand side, so we're going to bring down a 2 on the left side. And then the 3 is going to change on and go on the left side as opposed to the right side. And it's going to still equal x squared minus 7x. Okay, now we have to be wise about what just happened. We have 2 cubed equals x squared minus 7x. We talked about this at the beginning of this year. We have now a quadratic. All right, that is an important detail. Quadratic functions tell us that we need it equal to 0. If you ever see a quadratic function, we need one side equal to 0. So as I move over to this side here, if I do 2 cubed, that's going to give me an 8. Just simplifying that cubed function really quick. And I want it to be 0. Well, the easiest thing to move is this 8 over here on the left, because there's less terms, and I have to subtract that 8 at the end. There's no like terms with 8, so I'm going to make sure that I subtract it at the end. And when I work down, I'm left with 0 equals x squared minus 7x minus 8. All right, back to unit 2. We have a quadratic function. How can we solve for quadratic functions? One of two things. We can factor, which works probably 90% of the time. Or you can also use the quadratic formula, which will work every time, as long as you plug in the right values. All right. This one is factorable. So what I'm going to do is I'm going to set up an equation. And I'm going to say what multiplies to give me those two values I just underlined when I multiply them together. So what multiplies to give me negative 8x squared and adds to give me negative 7x. Remember your factoring rules. And if I think about that, that's going to be a negative 8 and a positive 1. And more importantly, I get to skip all the steps of factor by grouping and doing all that because my a value, this value in front of my x squared, was a 1. So now I know that I can factor it into the two factors I just found, and I have it as x minus 8 and x plus 1. And then from there, I can solve. So for the first one, my x value must be a positive 8. And for the second one, my x value would be a negative 1. All right. This question had two answers right now. But remember, we always need to go back and check. So let's check 8 first. If I took an 8 and I plugged it in for my x values in my logs, make sure that it doesn't come out as 0. Make sure it doesn't come out as a negative value. So if I plug in the 8, this one still gives me 8. This one will give me a positive 1. So 8 checks out. Put a little check mark. But if I plug in a negative 1, let's see what happens. Negative 1, negative 1. And when I simplify that, I still have a negative 1 on the first log, and then I end up with a negative 8. Okay? It doesn't matter if one of those logs is negative and the other one's positive. If any log turns into a negative, or if any log turns into a 0, you absolutely positively cannot use that as an answer. So because negative 1, when I plugged them in, gave me a negative with my logs, I cannot use it as an answer. So for question 3, my only answer should be x equals 8. All right. Let's continue on to question 4. Same kind of idea. All right. Focus on the left-hand side first. This time we're working with natural logs. That's fine. They all have the same base. I'm good to go. So on the left-hand side, focus on these two here. I see that I am subtracting, which is going to tell me to use the quotient rule, which means I need to divide. So when I combine these, I have ln x plus 2 goes on the numerator, 4x plus 3 goes on the denominator. And it still equals ln of 1 divided by x. Okay. Now, let's pause here for just a second. Remember those questions if we have the same base on either side, we can just compare the exponents. So if I looked at this example here, you guys would tell me that since my exponents, or excuse me, since my bases are the same, my exponents must also equal one another. So you would tell me that in this case, x would have to equal 5. All right, we know that rule with exponents. The same thing applies with natural logs or just logs in general. If I have the same base, so if I'm looking here, remember that natural log is the same as log with a base of e. They still have the same base. I can focus on just the main term and set those main terms equal to one another. Okay, the same rule applies for exponential as it does for logs. That's the beauty of logs. It's not as terrible as it looks. All right. So once I see that they have the same bases, I can set them equal to each other. X plus 2 divided by 4x plus 3 equals 1 over x. So we have a fraction equaling another fraction. More important, it's saying equals. So we can actually cross multiply, which is very nice. So I'm going to multiply the numerator, x plus 2 times x first, moving to the right here. So that's going to give me an x squared plus 2x. Make sure you multiply to both terms. And then I'm going to multiply the denominator, 4x plus 3, times that 1, which is still going to give me 4x plus 3. All right. Same rules. You see a quadratic, that should be a red flag that we need to set it equal to 0. All right. I like my a term or my quadratic term to be positive. That's just me. So I'm going to keep that on the left-hand side. And I'm going to move the two terms that were on the right. Make sure you're matching up your like terms. Okay, the minus 3 doesn't have a like term on the left, but I'm going to squeeze it in there right at the end because that's where my value needs to be placed when it's a constant. So I'm left with x squared minus 2x minus 3, and it is now equal to 0. Moving on, I can factor. Asking myself what multiplies to give me negative 3x squared. Oh my goodness, x squared. And what adds to give me that middle term of negative 2x. And when you think about your factors of negative 3, adding up to negative 2, you have the options of negative 3 and 1. All right. Once I have those factors, I can go straight into the factored form because my a value in front of that x squared was 1. So I can fill in x minus 3, x plus 1. Set it equal to 0 and solve. And let's check our answers. I have two answers again. Okay, they might both work, they might both not work, or one might work and the other one doesn't. Okay, we just have to do a quick check. If I take the 3, let's start with checking 3. If I plug that in, you're plugging it into every single log term. All right, so for the first one on the inside, I'll get a 5. For the second one, I'll get 15, which is still positive. That's what I'm focusing on, making sure it's positive. And then for the last one, I would get 1 over 3. So 3 is going to work. It gives me positive values in every scenario, so I am good to go. Then I'm going to go in and I'm going to check -1. So if I plug in a -1 here, -1 plus 2 is going to give me a +1, so that one works. But then when I plug in a -1 here, 4 times -1 gives me -4, plus 3 will give me a -1 inside there. So just because that one is negative automatically tells me that this will not work. Okay? It doesn't matter if all of them are negative, but as long as one of them is a negative on the inside of those parentheses, it absolutely positively cannot work as a solution. And then even if we checked here with that x with -1, we would still get -1 out. Okay, so it doesn't work for 2 out of the 3, but just because it doesn't work with one of them automatically makes it not a possible solution. All right. Question 5. This time we were given it in exponential form. So we are going to practice converting it to logarithmic form. Okay? Always try converting first and seeing if we can take it somewhere that we know or use our calculator if needed. So my base is 4. 4 was on the left-hand side, so I'm going to convert it into log with the base 4. And then 15 and x are going to change sides. So 15 is going to come to the left, and x is going to go to the right. So now it's set up to where x is all by itself, and I can type this in very nicely. All right. Now remember when we type it into a calculator, if you have the newer version, so if you're using the phone app or you're using like the skinnier calculator, you can type this function in just the way it looks. And the way to do that is to go and find your math button. Scroll down to the to the capital letter A, where it says log base. Hit enter. And then you will get what looks like log, box, and box. So you can fill in those exact values, 4 and 15, and then use the arrows to move from the left to the right so that you can type in your values. Okay? If you are using the older calculators, the ones that are a little bit bulkier, okay, you can still do this, you just have to type it in a different way. So this is the new calculator version, or the app version, I should say. And then the older calculator, you're going to have to type it in the change of base way, and you learn that in 3.2 and 3.3, okay? The change of base says that you're going to take it and you're going to make a fraction out of it. So the numerator is going to be log. It's always log. You're not going to worry about any bases or anything like that. And then you're going to take the main term first. So log 15. And then you're going to divide by log. And this is where you take the base and put it down below. All right. So one way to remember it, the base was in the basement. So when you write it as the fraction, keep it in the basement as that denominator on your fraction. Okay. One thing I do want to point out, if you are using the older calculator version, please make sure it likes to add parentheses when you type it in. Again, log is an actual button on your calculator, so you're using that log button. But when you type it in, it has an extra set of parentheses, so please be sure that you close off those parentheses before you continue to divide and then typing in your second log. Okay, if you don't close off those parentheses, it's going to think everything is in the numerator, and it's going to get all messed up and you will get the wrong answer. So make sure you close off those parentheses before you move to the denominator. All right. And again, always make sure that we are rounding to the nearest hundredth. And our final answer, depending on whatever calculator you use, you should get the same thing, should be 1.95. Okay, make sure you're getting that practice in on your calculators. You are allowed them on the test. All right, 2 more left. Question 6, we got some cleaning up to do before we convert. All right, the only times we can convert is when we have a perfect base and a perfect exponent and then a perfect term on the other side. All right, right now we have this 40 that's in front. Okay, that's not perfect because it's in front with my base. I only want my base all by itself. And the other thing I also have is this -3. Okay, so I need to get rid of those 2 things first before I can convert and move things around. So what's going to happen is, if you remember, just like how you normally solve for x, I want to add 3 to both sides first so that I can get rid of that. That will give me 40e to the 0.6x equals 240. And then I can divide both sides by 40. We will get e to the 0.6x equals, and 240 divided by 40 will give me 6. Now I have a perfect base, a perfect exponent by itself, and a perfect main term of 6 by itself. All right, so now I can do my conversions. And I'll put a smiley face because I know that I can do it now. Everything is perfectly by itself and manageable. So my base was e, it's on the left side, so I will keep it on the left, and I will put that base in the basement of my log. And the other 2 things will switch sides. So I'll have log base e of 6 equals 0.6x. You'll notice, or you'll remember, that log base e is the exact same thing as natural log, so I can change that out. And the great thing about changing that out is now I can put this in my calculator. You have a natural log button on the calculator, so you'll type ln, or you'll just put ln, plug in a 6, hit enter, and you'll get 1.791759469. Okay, I write all the values out until the very end because you shouldn't round in the middle of your work. You should round at the end of your work so that you don't get misconstrued answers. All right. From there, you want to get x all by itself, so we're going to divide by 0.6, divide by 0.6. Do that in the calculator. Round to the nearest hundredth this time because your x is now all by itself. And you should get 2.99. Okay. This one we don't have to check because x isn't part of my log any longer. X is in the exponent. I'm allowed to have negative values in that exponent. Okay, think of your exponential rules. You can have negatives because negatives make it flip into a fraction. So you are okay, even if it came out negative if you plugged in it. The only time you want to focus on zeros or negative values is if it's with your log. Okay, so because log wasn't given to us in the question, we are okay to continue. And the last one, question 7. All right. Question 7 is a little bit tricky, but we can do this one. All right, I will show you 2 ways. So if you prefer one way over the other, by all means, work out that way. So to get started, we'll stick to the same thing. So we have exponential, so let's see if we can convert to log. So my base is 2. I'm going to put that in the basement on my log. Keep the 16 on the left and put the 3x minus 8 on the right. As I do this one, I know that I can put that in the calculator. Okay, again, it's that special way. If you have the newer version, you click on math, go down to log base, and then you can type it in. If you have the older version, you need to have log 16 divided by log 2. Make sure you close off those parentheses that the calculator likes to add. And when you do that, you should get a perfect 4 out. Okay, depending on whichever calculator you have with you, you should get a 4 no matter what. Then you add 8 to both sides. You get 12 equals 3x. Divide both sides by 3. And your final answer is 4. Okay. That's the converting way. And that's 100% okay to do. All right. The other method that I want to try to work with, and it's with exponentials, so it's really up to you and what you prefer. But if I know that I'm working with, let me rewrite it here. If I know that I'm working with a base of 2, and I know that if I have the same base on either side, their exponents are going to have to equal one another. Okay, so the question here is, if I want to do it this way, how can I get 16 to have a base of 2? So I think about that for a second, and I see if it's even possible. So if I want to change 16 to have a base of 2, 2 to what power is going to get me back up to that 16 that I had originally? All right, you can use the calculator to double check, but you would want to say 2 to the 4th power is going to get me that 16. So I'm allowed to change that out because it's still giving me 16 at the end of the day, but now I have the same base on both sides. I don't need to worry about converting to log and typing it in wrong into my calculator or anything like that. I can just go straight to focusing on just my exponents and setting them equal to each other. And you'll notice it's the same exact values that we had over here anyways. So you're going to get there eventually. It's just a matter of time. Add 8 to both sides. And we get 3x equals 12. Divide by 3. And x equals 4. So there's method 1, where you can convert to log, or method 2, where you can try to get the same base and then focus on just the exponents, setting those equal to one another. Okay. The reason why I touch on this question specifically is because something very similar to this is on your test. All right. I just want to make sure that we are ready for that. All right. As always, my teacher notes are posted on Teams, so if you want to look back and see if you want to check an answer, whatever you need,